Hello dear learners, I'm Zinnah. I welcome you to my new video. This video is on extraction of aluminium. In the last video you got the extraction of iron. Iron extraction was basically the carbon reduction process, and today we're going to discuss electrolysis, the other process. Here we actually have two processes to extract metal. One is carbon reduction, another is electrolysis. To know which process is more applicable to extract a metal, you first need to have idea about reactivity series of metal. Here in the reactivity series, carbon is placed at the middle of the reactivity series of the metals, and when you need to extract any metal below carbon in the reactivity series, you can apply carbon reduction process because carbon can displace the metals from the compounds. But the metal, if you go for extracting any metal above carbon in the reactivity series, you cannot apply this method because carbon being less reactive than the metals above carbon, the reactivity series cannot be displaced, cannot be extracted by carbon. So here we get the other way, which is electrolysis, the most common way. Here first you need to have the ore of aluminium, which is aluminum oxide, recent aluminum oxide, and first you extract the ore and then clean and then grain into small pieces, make ready for chemical treatment. Then aluminum oxide needs to be heated to melt, because for electrolysis you need to have mobile ions. Here the big problem is the melting point of this is close to 2000, so this is very expensive to heat to melt aluminum oxide, and the scientists have discovered a solvent which is called cryolite to solve this problem. The cryolite is basically another ore of aluminium, which is sodium aluminum fluoride, is a compound. This is also solid. First they heat to melt the cryolite, and they make a liquid of the cryolite. This is solvent. Here the cryolite needs relatively less temperature, which is 1000 here, to melt, and then they dissolve aluminum oxide in the solvent. So you get here mobile ions, and this can be used as electrolyte. For the electrolysis you need to have a very big tank and coated with graphite. This graphite coating is used as cathode in the electrolysis. Then the tank is filled with the molten aluminum oxide, molten alumina with the cryolite, and then some heavy thick graphite anodes are placed in the electrolyte, and all the anodes are connected to the positive pole of a big powerhouse, and the wall there, wall of the container, wall of the tank, which is basically and in the electrolyte there are two types of ions. Basically you get one is aluminum ion, which is Al3 plus. This Al3 plus or aluminum ion move to the cathode, which is the wall of the container, and then they gain electrons to form aluminum metal. And the temperature of the container is very high, it's close to 1000. So at this temperature the aluminum metal forms there as a liquid, so that sinks at the bottom of the container, and from outside of the container when you tap out you can easily get the liquid aluminum out. And the other reaction at the furnace is the reaction at anode, which is by the oxide ions. The oxides of aluminum oxide approach to the anodes, and they lose electrons to form first oxygen atoms. Then two of the oxygen atoms pair up, combine to form oxygen gas, and there is a big agitation or bubbles of the oxygen gas that evolve, and oxygen escapes the container. Here we got another problem of the extraction of aluminum, which is the thick graphite anodes. The anodes are basically carbon. Carbon do not react with the oxygen at normal temperature, but the temperature is very high, so at this high temperature the carbon anode reacts with the oxygen that forms that anode, they react away to form carbon dioxide. So when carbon reacts with oxygen to form carbon dioxide, then the anode gradually decay. So when the anode decay, that becomes slim, and this is why the reaction slows down, because that gives less surface. So after regular intervals the anodes need to be replaced, and then this is also a cause of being expensive of the extraction of aluminum. But another thing, one thing is good here, which is you get pure metal. In the electrolysis just you get metal with no other impurities. So this is a good thing with the metal extraction. But not only aluminum is extracted with this process, any metal above carbon Suppose here you get calcium can also be extracted. Suppose melt calcium oxide and get calcium ion and oxide ion. If you localize, and you will get calcium metal from calcium ion, and oxygen gas will also form there. So this is how we can extract the reactive metals from the compounds. The process is electrolysis. So I think the process is easy, and especially easy to study, easy to understand. I hope that this has made your concept of extracting metals very easy. So thank you very much.